All right, thank you for joining me today with another page of notes with Mr. Jankowski. We've got a really big page here. This is a lot of notes today, and I apologize for that. So today, definitely take your time with this and make sure that you stop the video and write down what you need to write. Also, there will be some extra graphs here I have on the side, and there's just not much room on your page in your notebook, so I'd recommend taking notes on a separate piece of paper as well, and maybe gluing that into the back of your notebook. Maybe making a graph like this so that you can label some things and follow along. I think it will be a little bit easier if you're prepared. So definitely get page 84 out of your math notebook, and then also maybe another sheet of paper for some extra stuff. So I'm going to zoom in here. You can see I have some things pre-filled. And we're going to start off at the top. We're going to be covering vocabulary for modules 12 and 14 here. This covers the coordinate plane. So we were graphing on a number line last week and the week before. We were graphing inequalities. And when we were graphing those numbers on the number line, that was just the x-axis. Now we're going to include both axes, the x-axis, which is the horizontal axis, and then the vertical axis, the y-axis. So we have here the very first definition, axes. The two number lines are called the axes. So you have the y-axis and you have the x-axis. Let's do that in green. Together they are axes. So we're going to be graphing two dimensions. All right, so the x-axis and the y-axis. I'm going to put this here, x-axis and y-axis. You may already know this. There is also a z-axis. We're not going to be worrying about that this time. But a z-axis will allow you to graph in three dimensions instead of just two. So let me fix this real quick. All right, y-axis. Okay. And you can see here, quadrants is the next vocabulary word. We've got the two axes divide the coordinate plane into four quadrants. And these quadrants you can see are labeled. We've got quadrant 1, quadrant 2, quadrant 3, and quadrant 4. So they go in kind of like if you start in quadrant 1 here, you're moving in a counterclockwise rotation. So something that you'll need to write down. Remembering that is kind of hard to remember. One thing that I also want you to remember, and you can write this down too, is that every number or every ordered pair in quadrant 1 will be positive numbers. Every ordered pair in quadrant 2 will be negative, positive. Quadrant 3, negative, negative, and quadrant 4, positive, negative. That's going to come in more detail later. In fact, let's move on to ordered pairs. Now, I have a really long definition for ordered pairs here. This is straight out of your book. And I don't know if we're going to, I don't think you definitely need to write this down, maybe part of it. But it says in your book that an ordered pair, move this so you can see everything. An ordered pair is a pair of numbers that gives the location of a point on a coordinate plane. The first number tells how far to the right, positive, or left, negative, the point is located from the origin. The second number tells how far up, positive, or down, negative, the point is located from the origin. So let's not write down that definition. This is straight from the book. I just copied and pasted that there on this Jamboard for my own. And then, of course, these notes are available to you in Google Classroom, so you can look at that too. But an ordered pair, and I want you to write this down here, includes the x coordinate and let me erase that here, hang on, and the y coordinate. And what this allows you to do, sorry, I'm having some technical difficulties here. What this allows you to do is locate a point on a number line and two number lines, and then figure out where. I'll just show you here. Okay, so let's just do this. I'm going to show you what an ordered pair would look like. You would see an ordered pair like this. We might have X. You know what? Let's do this. The ordered pair look like this, X and Y. And it might be, so the first number is the X coordinate, the second number is the Y coordinate. You might see something like 3, and then the Y coordinate might be like 5. And then on the number line, or on the graph rather, I'm sorry, on the graph, and I'll show you up here on this graph, you would look at the x-axis first. So you look at the x-axis and you'd go to 3. So 1, 2, 3 on the x-axis. And then 5 on the y-axis. So you'd go up to 5 on the y-axis. And then these two points converge right here. And this would be the ordered pair 3, 5, the location of that. So they don't really give you a whole lot of space here in the book. To give you another example, I have this on the side. I think this is kind of hard to see. So I'm going to zoom out a little bit more. And I want to show you over here. I have this bigger graph. So if we wanted, or the bigger coordinate plane rather, to graph. If I wanted to graph the ordered pair 3, 5, I'd find 3 on the x-axis. And they explain this in that definition. It's kind of hard to explain, or kind of hard to read the explanation from the book. But you find 3 on the x-axis, go up to 5 on the y-axis. So 3 on the x-axis, up 5 on the y-axis. This would be the point, the ordered pair 3, 5. And of course, this is in quadrant 1 because both numbers in that ordered pair are positive. So I'm going to zoom out again. I know I'm going kind of fast and I have a lot going on this page, so please just bear with me here. The next definition we have is naming points. Naming points. And when you name a point, you're giving a point on a graph a name. So you're giving it a designation. So designating a point on a graph. So to go back to our other example here, this point 3, 5, I might name this point point A. And then instead of saying, okay, where's the points on the graph of the ordered pair 3, 5, I can just say, where's the point on the graph that I named A? Okay. Oftentimes points are named with letters. So often points are named with letters. Points on a graph. Oh my goodness. Let me erase this. There we go. With capital letters. It doesn't always have to be capital, but they are often named with capital letters. I'm sorry, guys. I'm using my PC today, and it's not working very well with my tablet slate. So bear with me, and if you can't read this, slow down. Listen to the to what I'm saying, and it should make a little more sense. So I named this point A. No, I could name another point here on this graph. Let's say I had another point here, and this is -4, sorry, -5 on the x-axis and 5 on the y-axis. I could name this point B, for example. And then another point I could name C. just designating those points so that you can easily find them. All right, so graphing points on a graph. Well, we already talked about that. We already did that over here, and that's actually mentioned in our definition here for ordered pairs. So you know what I think I'm going to do is take this and actually plug it in here. So graphing points, I'm going to rewrite it though because it's too hard to fit that whole thing. Okay, so I'm going to put here graphing points. Let's use a text box. I'm trying to clean this up a little bit. Now, text boxes with Jamboard get really crazy, but they you can fill them out and figure out how they fit a little easier when you're done writing. So I'm going to write this here, first number. You know what? I'm going to change that actually, the x coordinate. The x coordinate is found first on the x-axis. It's probably painful for some of you to look at, so let me fix this now. So a Jamboard, if you're using a text box, you can, once you get it going, you can make it a little bit smaller and it fits a lot better. So here we go. The x coordinate is found on the x-axis, the y coordinate on the y-axis. And where those points converge, points meet on the graph on the coordinate plane is where point is placed. There we go. Okay. Now that this is what I want it to say, I can make it a little bit smaller there. So the x coordinate is found first on the x-axis, the y coordinate on the y-axis, and where those points meet in the coordinate plane is where the point is placed. Okay. Okay, let's see this. And where those locations meet on the coordinate plane, I'm going to say locations meet. That makes more sense. All right, so let me just give you a demonstration of this here with our coordinate plane that we have here. If I was to graph this ordered pair, so I wanted to graph this ordered pair as a point on my coordinate plane. Let's say the ordered pair 3, -2. First, I would find 3 on the x-axis. So let's find 3 on the x-axis. There's 3 on the x-axis, right? Then I'd find -2 on the y-axis. There's -2 on the y-axis. Now, where those points converge, maybe if I use red, this will be easier to see. And where those points converge on the coordinate plane is where I would graph this point. So that is where we find the ordered pair 3, -2 on this coordinate plane. And since I'm here, I might as well name this point. Let's name this point point C. Okay, so graphing points on the coordinate plane. Let's move on to reading scales. Now, we're going to see this a lot. I actually have a really good example down below here, sort of. But well, let's do this. When you look at a graph or a map, for example, like if it has a scale, like a distance scale, or a graph that has a scale, you might see something like this. You might see for every point on the graph, or for every point on the graph. And let's see this. Let's do this. All right, sorry for that little pause there, but going back to reading scales, the definition from the book is just hard to explain this. The definition from the internet actually is this: a scale is a set of numbers that help to measure or quantify objects. So a scale on a graph shows the way the numbers or pictures are used in the data. So I'm going to put that here for the definition. A scale on a graph is used, or a scale on a graph is used to show the way numbers or pictures are used in the data. Okay, so for example, you might see like these. Let's give you an example here. Reading scales. So you might see this being 1, 2, 3, 4, 5, 6, and then on the side it might say on a scale might say a reading scale might say for every one on the y-axis equals 5 children in the classroom or something like that. So if you have or if you're dealing with a large number in your data and you don't want your graph to go into these large numbers, then you might have a scale on the side that shows that the graph is compressed and that you're showing smaller numbers on the graph that represent larger numbers in real life. So we'll run into that quite a bit when we do homework and independent practice. So we'll talk about that more. Now, reflecting points. This is another one that is kind of hard to explain without lots of examples. But let me put this here. Reflecting points are points on a graph that are in opposite positions. Or, you know what, I want to say mirrored positions on a coordinate plane. Okay, so reflecting points, to give you an example, we have C over here, 3, -2. If I wanted to have a reflecting point for that, it would be the exact opposite on the other side here. So -3 on the x-axis and -2 on the y-axis. Let me make sure that's right. Yeah. So right, that would be a reflecting point. So we've got -3, -2. So this is point D. I could say these are reflecting points. If you think about it, if you were to fold the graph in half like a piece of paper, those points would touch. If I was to fold it on the the y-axis, those points would touch. So I could put here on the side, if this helps, points C and D. Erase that comma. Reflect. They are on exact opposite or mirrored points on the graph, or on the coordinate plane rather. All right, moving along. And I know this is a lot of information, so just bear with me. Finding distance. And this is something that we're going to be going into a lot more detail in guided practice as well. So I want to just give you a quick little thing here. We don't really have a lot of space, so just give you a quick example. finding distance between points. So you're finding the actual distance between 2 points, not necessarily uh, distance between points and a number line. So the distance in units between 2 points. So let me give you an example. Give you an example here. We have B and A. So if I wanted to measure the distance between B and A, I would really look at really the x-axis, because the difference here, I can see the distance between the x-axis. So if I were to measure this distance between these points, okay? So the distance between B and A. Well, if I look at the x coordinates, I have 5 and 3, but I need to look at it like this. I need to look at the absolute value of -5 and the absolute value of -3 or +3. So I'm going to add these absolute values up. Okay. So -5 and 3 is what I'm doing here. Now, -5, absolute value of -5 is just 5. So we can look at it like that. So I'm going to have 5 plus 3, and that equals 8. So the distance between B and A, I'm going to put point B and A, is 8. And we can check this if we want to. I can measure or count the distance just by counting the different units here. So 1, 2, 3, 4, 5, 6, 7. Oh, 8. Let's try that again. 1, 2, 3, 4, 5, 6, 7, 8. I missed that. That's kind of confusing, isn't that, on this particular graph? So yeah, the distance between points B and point A is 8. So that's how you find distance. We're going to be doing a lot more of that later on. This is just a brief explanation of finding distance on a coordinate plane. Finally, we have two more definitions, and these are fairly difficult for students to understand. And again, we're going to be going over this a lot. But you'll see independent variables and dependent variables. And I want you to take your time to write this down. An independent variable is the quantity depended on in the situation, is called the independent variable. And I just noticed I have a misspelled word here, don't I? So let's fix that. Edit. And then we also have the dependent variable is the quantity that depends on the other quantity. And this is called the dependent variable. Now we have an example here. We have a freight train moves at a constant speed, the distance y in miles that the freight train traveled, and after X hours is shown on the table. Now, the dependent variable, do this here. The dependent variable is the distance the train is traveling or traveled. Now, the dependent variable is y in this case. It's the distance the train traveled, because the distance traveled depends on the independent variable. Which is the amount of time that it traveled. So if the train doesn't travel at all, right, it can't go anywhere. The time that it travels is independent from the distance, because the distance depends on the time it takes to travel there. So you can see here in this example, we have if the train traveled 0 hours, it goes 0 distance. But if it goes 1 hour, it goes 50 miles in distance. 2 hours, 100 miles in distance, and 3 hours, 150 miles in distance. So the independent variable in this case is the time traveled, and the variable that depends on that, how much time was traveled, is the distance the train can travel in that amount of time. So this is a lot of information for you all to write down and look at. I hope that you got some good information from this. And please remember that these notes are saved. They're archived in Google Classroom. So it is really handy to write these notes down. But if you need to, you can look at these notes in Google Classroom. They're all there for you. And you can look at things that you missed, go back and watch the video again if you need to. Thank you for watching this video, though. This is a long one. I hope it helped. And I'll see you in the next video. Take care, everybody.